Good evening. My name is Tharsana Ravi. My matrix number is 27723. Today I would like to do a presentation on my final individual assignment for the course of Introduction to Mathematical Economics with the course code BEEQ1013. This presentation is done for my lecturer, Dr. Zalila Binti Othman. The question given is, my company can produce at most 120 units of handmade shoes labeled perfect fit each year. The demand equation for perfect fit is P equals x square minus 100x plus 3200, where P is price and x is the quantity produced. The average cost function is also given, which is 2 over 3x square minus 40x plus 100,000 over x. In this question, there are two sections. In the first section, we have to do the following, which is A, find the total revenue function R. We can find the revenue by multiplying the price and the units produced. The price function is given, so you have to multiply that function with x, and we'll get the answer of x cubed minus 100x square plus 3200x. And B, we have to find the total cost function C. To find the cost function, we have to multiply the average cost with the units produced. The average cost function has been given in the question, so we have to times that with x, and we'll get the answer 2 over 3x cubed minus 40x square plus 10,000. For C, we have to find the total profit function. Profit can be found by subtracting the total cost from the total revenue. We have found the total revenue function and the total cost function from the previous question. So we have to minus these two functions. And I put them in bracket so that it would be easier to change the symbol from negative to positive. And we get the answer of 1 over 3x cubed minus 60x square plus 3200x minus 10,000. In D, we must determine the output level that will maximize the profit and the amount of profit obtained. For this, we will have to find the first derivative of the profit function, which is x square minus 120x plus 3200. And then, using this function, we have to put it as equal to 0. By that, we will be able to find the values of x, which are 40 and 80. So we can see that the output levels that will maximize profit are 40 and 80 units. Next, we have to substitute the values of x into the profit function. By substituting 40 into the profit function, we get the profit of $43,333.33. By substituting 80, we get $32,666.67. By this, we can see that the maximum amount of profit is $43,333.33, which will be obtained by producing 40 units of shoes. Whereas the second highest amount of profit would be $32,666.67, which will be obtained when they produce 80 units of shoes. In the second part of this question, based on the profit function, we have to A, find the y-intercept. For this, we have to set x equals to 0. So in the profit function, we have to substitute all of the x with 0, which will give us the answer of negative 10,000. Negative 10,000 is the y-intercept. For B, we have to find the intervals where the function is increasing or decreasing. We have found the values of x from the first derivative earlier. The values of x are 40 and 80. There are two values, which means there are three intervals, which is 0, 40, 40, 80, and 80 to 120. The maximum is 120 because in the question it has been stated that their maximum production is 120 units. And there is no negative units, so the lowest amount is 0. So between these intervals, we have to substitute any value in between the intervals into the first derivative. So I chose 20, 60, and 90. For 20, I got 1200. For 60, I got negative 400. And for 90, I got 500. We can know whether they are increasing or decreasing. If fx is more than 0, it means they are increasing. If fx is less than 0, which means negative, it means they are decreasing. We can see that the interval of 40-80 is decreasing because it is negative, whereas the interval of 0-40 and 80 to 120 is increasing because it is positive. For C, we have to find the intervals where the function is concave upwards or concave downwards. For this, we have to find the second derivative. The second derivative can be obtained by using the first derivative. The second derivative is 2x minus 120. Then, we make 2x minus 120 equals to 0 to find the value of x. The value of x is 60. There's only one value of x, which means there are two intervals, which is 0, 60 and 60, 120. We have to substitute any value in between these intervals into the second derivative. I chose 20 and 90. For 20, I got negative 80, and for 90, I got 60. We can find whether they are concave upward or concave downward. If fx is more than 0, it is concave upward, and if fx is less than 0, which is negative, it means it is concave downward. So we can see that the interval of 0, 60 is concave downward, and the interval of 60, 120 is concave upward. For D, we have to find the inflection point. We have found the value of x from the second derivative, which is 60. So this value, we'll have to substitute it into the profit function. So substitute x with 60 and we get the answer of 38,000. So this shows the inflection point is 60 and 38,000. For E, we have to draw a graph of the profit function using the information from the questions earlier in section 2 and show the absolute maximum, absolute minimum, relative minimum and relative maximum points. We have 4 points earlier, which are 0, 40, 80 and 120. So we will have to substitute all these values into the profit function and we'll get the y value. For 0, we get negative 10,000. For 40, we get 43,333 and 33 cents. For 80, we get 32,666 and 67 cents. For 120, we get 86,000. When we plot the graph, we will be able to see which is the absolute minimum, absolute maximum, and relative minimum and relative maximum. From here, we can see that 0, negative 10,000 is the absolute minimum, 120 and 86,000 is the absolute maximum, 40, 43,333 and 33 cents is the relative maximum, and 80, 32,666 and 67 cents is the relative minimum. For F, we have to label the graph and write all the important coordinates and intervals. The absolute maximum, absolute minimum, relative maximum and relative minimum has been found earlier, and then we can see that the increasing is on 0, 40 and 80, 120 and is decreasing on 40 to 80. We can also see that is concave upwards on 60, 120 and concave downwards on 0 to 60. I would like to end my presentation with a quote by William Paul Thurston, who is an American mathematician. He said, "Mathematics is not about numbers, equations, computations or algorithms. It is about understanding." That's all from me. Thank you.